So source is nothing but voltage. Voltage is nothing but the tap, and the pipe what we have is nothing but the resistor, and the current which flows in this pipe is nothing but current. This how to understand the beauty of Ohm's law. And hi everyone, welcome back to our channel. Today we are going to discuss about the definition of Ohm's law and what are the drawbacks of Ohm's law, where we call it as the limitations of Ohm's law. Here you can see a beautiful diagram to understand the Ohm's law. Okay, actually the what we are going to apply is nothing but voltage. Okay, what is developed in a network is nothing but current, but which opposes the flow of electron is nothing but resistance. Okay, so this is the property of an element. What we generally apply, this is called as source. Voltage is called as source, and the developed current is called as effect. Okay, now let's try to go in deeper to understand what is meant by an Ohm's law. Okay, so generally Ohm's law is studied at constant temperature. At constant temperature, or when the temperature is constant, the voltage applied to an material, voltage applied to an conducting material, voltage applied to a conducting material. What is this name of this conducting material? Means it's nothing but an wire. Okay, wire which has a resistance of R ohms. This is directly proportional to the voltage developed. Directly proportional to the current through it. So this is the standard definition of Ohm's law. Let's try to understand the definition. Okay. So here we are applying the voltage. Okay. So whenever you apply a voltage to an resistor, okay, then a current is developed in the circuit. Okay. That's why the applied voltage is directly proportional to the current developed. Okay, where voltage we are applying and developed is current. Okay, so first one is voltage and developed component is current, and I can say that current will develop only when voltage we are applying and the resistor is offering resistance. Then only current is developed. Okay, that's what the standard definition. Let's try to come across the definition. At constant temperature, the voltage applied to an conducting material or a wire or a resistor is directly proportional to the current through that material. Okay, so that's how I can say that voltage is proportional to the current developed in the circuit, and this resistor is having a resistance of R ohm. Now let us try to replace this constant of proportionality. Therefore, I can write down V is equal to I into R. This is the standard formula of Ohm's law. What we are applying is voltage. What it is developed is current. Therefore, voltage I am going to call it as source. Current I am going to call it as effect. All these are developed only due to the presence of resistance. Resistance will decide how much amount of current has to flow. For example, current I is equal to, from the Ohm's law, V equal to IR. How to write down the current? Current I is equal to V by R. Okay, if the network is offering less amount of resistance, then the maximum current will be flowing. Similarly, the second case, current I is equal to V by R. Okay, now the network is offering highest resistance, then low amount of current will be flowing. So the magnitude of current is decided by the value of resistor. This resistor is, if it is low, current is maximum. If the resistance is high, therefore current is minimum. Okay, this is how we are going to have an inversely relation. Resistance is minimum, current is maximum. Resistance is maximum, current is minimum. So this kind of relation is developed by a scientist called Ohm. That's why this law is called Ohm's law. Okay, now let us try to understand in deeper. Okay, we need to draw the IV characteristics of an Ohm's law. So let's try to have the formula, basic formula. V is equal to IR. Okay, now we have the standard formula. It's nothing but Y is equal to mx. Here the x quadrant and y quadrants we are going to mark. The x quadrant is nothing but current, y quadrant is nothing but the voltage. Okay, now when you plot these characteristics, on the x-axis you are going to have the current, on the y-axis you are going to have the voltage, and the slope of the line, okay, this line is having an slope m is equal to r. This value is also of positive. Okay, therefore these kind of characteristics are called as the IV characteristics of an resistor. Okay, similarly you can do it in one more style also, okay, where I can say that current I is equal to V by R. Okay, now let's try to link it in one more style. So what is the standard formula of resistance, standard formula of straight line is y is equal to mx. Here y axis is nothing but current and x axis is nothing but voltage, and the resistance is 1 by r. Just it will be changing and nothing else. So people get confused, nothing else to confuse here. Here the x axis is what? Voltage, and y axis is nothing but current, and the slope of the line is changing. That's what the beauty how to understand, which is 1 by r. So therefore, I can call both as IV characteristics of a resistor, or we can call it as the VI characteristics of an resistor. Okay. So this is all about Ohm's law. Okay. So when you see the diagram, you can beautifully understand how resistor is controlling the flow of current. Now let us try to understand the drawbacks of this Ohm's law, or way we call these drawbacks are limitations. We have some limitations in applying this Ohm's law. Okay, let's try to discuss the limitations one by one. Okay, first limitation is it cannot be applied to unilateral element. Okay, so we cannot apply our Ohm's law to unilateral elements. Okay, this is very important. You need to understand unilateral elements. The meaning here is unilateral means uni means one, lateral means they allow only in one direction. So these unilateral elements examples are, so these unilateral elements will allow the current, they allow the current only in one direction. So what are those elements which allow the current in one direction is first one is an diode. Okay, so diode will conduct only in forward bias. Okay, you can see the diode I'm connecting in forward bias, then only it will conduct. So therefore I can say our Ohm's law cannot be applied in the case of an diode. Okay, and our Ohm's law cannot be applied for transistors. Okay, and it cannot be applied for bipolar junction transistors, and it cannot be applied for triac, and it cannot be applied for silicon control rectifier. For all electronic devices our Ohm's law will fail. Okay, so for all the electronic components our Ohm's law never satisfy. It may be a diode or it may be a Zener diode. For all this our Ohm's law is not valid. Then for what the Ohm's law is valid? It's a very important question. Ohm's law is valid for bidirectional elements. Okay, bilateral or bilateral elements. Then you need to understand what is an bilateral elements. Bi means two, lateral means direction. So it is applied for element which allows the current in both the directions. Let us try to take a resistor. Okay, now we are applying some voltage. Therefore, the current is flowing in forward direction, and I can say that the resistance offered is R. So this resistor also will allow the current to flow in opposite direction also. So it is allowing the current in how many directions? Two directions. Therefore, we can apply Ohm's law for an bidirectional element. Those are resistor and inductor and capacitor. Okay, wherever you have resistor, inductor, capacitor, we can 100% apply Ohm's law. This is the first thing what you have to remember. And we cannot apply the Ohm's law for diode, transistor, and all the family of bipolar junction transistors and triac and all silicon controlled rectifiers. The first what you have to keep it in the mind. Coming to the second drawback. Okay, so this cannot be applied for non-linear elements. We cannot apply Ohm's law. It cannot be applied for non-linear elements. So we need to know about what are those non-linear elements. So these are also similar to unilateral elements. So for examples like diode, transistor families, transistor, bipolar junction transistor, as well as for silicon control rectifier. Here, current is, applied voltage is not directly proportional to current. The applied voltage is equal to square of current, or sometimes it may be cube of current, where we cannot say that we have a direct relation. When they are not having a direct relation, we cannot apply the Ohm's law. Now let us try to see the characteristics, how they are going to exhibit. Okay, so we had already seen the IV characteristics. Okay, now let us try to see these characteristics. Let us assume that we have voltage in x-axis and we have current in y-axis. Now I am going to draw the VI characteristics of an silicon controlled rectifier. So here initially we will apply the voltage, but as soon as you apply the voltage, it will not conduct. When you give the gate signal only, it will conduct, and this is called how the direction of current is there. Okay, so here in the silicon control rectifier, we may have anode, cathode, as well as gate. So if you give anode and cathode voltage, it will not conduct. It will conduct only when the gate signal is given. That's why this SCR is called as a controlled device. Okay, so this is a very good example to understand a controlled device. So when you apply the voltage, for example, I'm applying 10 volts across anode to cathode, it doesn't conduct. It will conduct only when we apply the gate signal, and automatically the current magnitude slowly increases. And when you apply the gate signal, this diode will act as a short circuit and it will try to flow the current in the circuit. Then automatically the current in the circuit will increase. So here we can see the relationship between the voltage and current is V is proportional to I square, where these kind of relations are called non-linear elements. This for all these non-linear elements, we cannot apply the Ohm's law. This already first time we discussed. This is how to understand why we are unable to apply Ohm's law in the case of non-linear elements. This is the second drawback what we have in the case of Ohm's law. Okay, Ohm's law. The third drawback is Ohm's law will not be applied in the case of a non-linear. So this is also the same what we have been discussed. And the third law is Ohm's law is very difficult in the case of complicated circuit. Okay, so calculating Ohm's law. So if you want to calculate the relationship between voltage and current, so calculating Ohm's law is difficult in the case of complicated circuits. We need to understand the definition or the concept of this sentence. Complicated circuits or network. If it is an electrical network, we have an voltage source, resistor, inductor, and if you have a diode, and if you have a closed path, and you have an transistor configuration, the closed path. So for all this, we cannot, you can see here, this will act as an electrical circuit 1. This will act as an electric circuit 2. This will act as an electric circuit 3. If you add all these circuits, then it is called an electrical network. For this complicated network, where it consists of bilateral elements as well as unilateral elements and non-linear elements, it is very tough to calculate the Ohm's law. That's what the meaning of this sentence. It is very tough to calculate Ohm's law in the case of an complicated networks. So due to this all these drawbacks, we cannot apply the Ohm's law in the case of complicated circuits, in the case of non-linear elements, and in the case of unilateral elements. This is how we draw the IV characteristics of a resistor as well as the VI characteristics of an resistor. Okay, so you can see here, so a layman concept also you can understand. So generally we have only voltage. Okay, so I will say one analogy to understand this. Why? Because when you learn with example, the things are very simple. Analogy here is this voltage. Let us try to consider we have in a tap in our home. Our tap is called as voltage potential. Okay, whatever is flowing, this current is nothing but current I is equal to Q by T. So this current is treated as the flow of water. Okay, so water pipe will act as an resistance. Okay, this is a perfect example to understand the Ohm's law. Okay, so if you control the pipe, okay, so automatically we can have more amount of water. If you make it in open, automatically current rate is also of very much slow. Okay, so everything is there. How you decrease the diameter of the pipe? Okay, if you decrease it more, okay, automatically more water will be pumped out. So that's how to understand uh, the analogy of an Ohm's law. Okay, so source is nothing but voltage. Voltage is nothing but the tap, and the pipe what we have is nothing but the resistor, and the current which flows in this pipe is nothing but current. This how to understand the beauty of Ohm's law and limitation. If you feel the content is useful to you, please give a like to the video and share with your friends those who are studying the same subject. And if you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so kindly support these sort of channels. Why? Because these are free channels for the development of students and faculty. Thank you for watching. We'll meet in another beautiful concept. Yours from